Hey everyone, today I want to talk about memory. Memory is the hidden engine behind continuity and context in all AI products. LLMs only have short term memory. They are like Drew Barrymore in the movie 50 First Dates. For those who haven't seen the movie, Drew Barrymore doesn't have long term memory. She only remembers what happens during the day, and when she goes to bed she forgets everything that happened in the past several years. So what Adam Sandler does is he makes a video showing that they are a couple and asks Drew Barrymore to watch the video every morning, because otherwise she won't know that he is her boyfriend. That's hence the name 50 First Dates. They he tries to impress her 50 times and so on. um, you know Applications, AI applications, need to store facts for LLMs the same way Adam Sandler creates that videotape and shows it to Drew Barrymore every morning, so that she understands the context, and she regains the memory and understands the context. Now, why should product managers care about memory? They should care about memory for a few reasons. First, is continuity, because it provides a better user experience. If your AI application remembers what you did last week or last month or yesterday, then the user experience is much better. Second is personalization. Memory allows your AI application to tailor responses and workflows to each user, creating defensible stickiness. Third is efficiency. If your LLM doesn't have to read every document and a lot of content to understand and answer your question, um, it makes the process very efficient, and so that is important as well. Learning compounds value. The more your AI application learns about your user and stores that information and uses that information to respond to the user, the more the value of your AI application for your user. So and the more and it doesn't grow gradually, it compounds exponentially. The more information you have, the exponential value you can provide to your customers, and all of this creates a competitive advantage, which is an important mode for AI application providers, builders and providers. How does this work? The mechanics. How do we give AI long-term memory? Since LLMs are stateless, like Drew Barrymore in the movie, the application must act as the external hard drive. We achieve this through a process called retrieval augmented generation. Think of it as giving the LLM a cheat sheet of relevant information and relevant memories before it answers. There, it's a three-step process. First there is a vault, there's a storage, there's a vault. You store information about your user in the vault, and then when the user asks your question, then there is a retrieval process. You go to the vault and retrieve information about that user, and then you send that information along with your prompt to the LLM, so that the LLM can answer things, in context, answer things much faster and provide a far more valuable experience to your customer. The takeaway for product managers is memory isn't magic, it's an engineering component, usually a database with a retrieval layer that needs to be planned on your roadmap, and can be used to your strategic advantage. I To demonstrate this concept, I built a small app where I will save a fact, and then I will save a fact in the sense I will explicitly tell the application to store this information about me, and then I will show that we can retrieve the facts. We can view all the facts the application has stored about me, and then I will chat with my application. I'm going to make the assumption that this is a chat application, and ask the application a question about a topic that it has stored, and then we'll see if it uses its long-term memory to answer my question. And in the second part, we'll also see how this information can be modified, where this information is stored and how this information can be directly modified or appended to. We'll open a file and see how we can modify that information. And then third, we'll also look at how this information can be stored in a knowledge graph, along with relationships and how it can be visualized, and so on and so forth. So let's start with, I want to save a fact. I'm going to say, I like muffins. Okay. And then I'm going to explicitly tell the application to save the fact. In real world applications, the users may or may not tell the application to remember something about us, about themselves. In this case, the application itself should recognize certain things about the user and decide whether to store it in long-term memory or not. LLMs like Claude and OpenAI also allow you to explicitly say, "Remember this about me," and then store that information. So here I said I like muffins, and before this I've said a few things about myself. So let's see what are the facts this application knows about me because it has stored that information in its long-term memory. So here are the stored facts. I love almonds, I love cappuccino, I like muffins. So it has stored that information about me. And where is that information stored? Usually in some memory file, in a database or a JSON file. Um, so that that information is stored here. And then if I say remove something from here, and say refresh my application and view my facts, I should now just see I love cappuccino because I removed the additional information from there. And because the this particular AI application has stored information about coffee, about my coffee preference, if I ask it, what should I drink? What should I drink today? Ideally, what it should do is it should go and check the memory and then give me an answer based on that memory. I guess it'll say you should drink a cappuccino. Let's see what it says. Okay, yeah, it says, since you love cappuccino, why not treat yourself to a delicious cappuccino today? It is a great choice to enjoy your favorite coffee. So, see what happened here. First, we stored that information in a vault, in this case, a simple JSON file. And then, um, when I asked the question, what should I drink today? What the application did is it retrieved information from the vault, sent it to the LLM along with my question, and then the LLM looked at the information in the long-term memory, and then it used its own judgment and then composed this answer saying, since you love cappuccino, why not treat yourself to a delicious cappuccino today? This is a simplistic example, but you get the idea of storing in a vault, retrieving long-term memory, providing it as a context to the LLM so that the LLM can give me a more relevant and more valuable and more appropriate answer. And so this is the storage, the editing part, and the retrieval part. Now we can also store it. Now what it did in the JSON file, you'll notice that it stored whatever I said verbatim. I said I love cappuccino, and it stored exactly that. However, we can also store it in a more intelligent way. For example, you can store it in a knowledge graph, um, and in a knowledge graph, the concepts are more sophisticated than simply storing what I said. For example, a knowledge graph has um, multiple entities like person, concept, object, place, time, preference, fact, and so on. And then it also stores that relationship. And this is a visualization of that knowledge graph. This is where the knowledge graph is stored as a JSON file. Usually it can be stored in a specialized knowledge graph database. For the sake of this prototype, it is stored in a simple JSON file. And here it maps all the information. Prashant is a person, um, and he is a user. That's also a person. He is a product manager. That's a concept. And then Prashant has likes almonds, which is an object, and then he likes a cappuccino, which is also an object, likes a muffin, likes coffee, they're all objects. And then he has, or he hires, let's say, has a team of forward deployed product managers. That's a concept. Uh, and his favorite coffee is a cappuccino. It's a preference. Things like that. You can store all information about your users in a knowledge graph, so that retrieval becomes far more sophisticated than simply reading a file. So hope that gives you an idea of why memory is important, how memory can be a competitive advantage, the simple mechanics of storing, retrieval, and generation using memory, and also a real world understanding of how memory is stored in a vault, how memory can be edited, how memory is retrieved, and how it can be visualized in multiple forms, in simple files or as a knowledge graph. Hope that helps.